Hello everyone. Today we are going to learn key index searching and sorting. This is also known as counting sort technique. In our previous class, we saw basic searching and sorting techniques. We saw two types of sorting: insertion sort and selection sort, and one type of searching technique which was binary search. We saw the efficiency of binary search was really great, and it was more efficient than the traditional sequential search. Today we are going to learn this key index searching, which will give a more better performance than the binary search technique. Let me explain you first how this techniques works, then we are going to look into an example for better understanding. So basically, key index searching and sorting techniques in, includes the generation of an auxiliary array. That is, we are going to have an additional array which will have all the values of A as its index. For example, if the values of A has sequence 1, 2, 3, 4, 5 till 8, my array B will have all these values as an index for this array. Therefore, the capacity for my array B should be the maximum value present in A, and the values present will be the indexes. That means we are going to have an array with the maximum plus 1 as a size for the auxiliary array. So look at this example where I have generated my array B. So it has indexes from 0 to 8. Why we have to have as a capacity largest plus 1? That because I want this largest value to be a valid index, and for that we know that arrays start from 0, so we have to have the capacity plus 1 to contain this as a valid index. After generating the B, we have to populate this array according to the values that are contained in my array A. Okay, so the capacity for this kind of auxiliary always should be largest plus 1 to have a valid index, as the maximum value of A is 8. Okay, after that we have to count the values which are inside the array A. So what we are going to do, whenever we have the value 5, for example, we are going to the index 5 in my array B, and we are going to increment it by 1. For value 1, we are going to my array B index 1, and we are going to increment the value, or we are going to update the value as 1, and so on. So we'll get this B array where we have counted all the values. Okay, after having this auxiliary array populated, finding any valid key which are within this specific range is more easier. For example, if I have to find out if the value 8 is present or not, I have to go just the auxiliary array B and look for the index 8, and look if the index 8 contains 0 or 1. If it is not 0, that means the value is present in my array A. So do you see, just only by one checking we get the value easily. So it's more efficient the binary search, where we are partitioning the array in two parts, and minimizing the performance of the sequential search. So here it takes actually constant time, that is by one time, one checking we just get the value. So this is the searching technique. What about the sorting? How we can sort by using the auxiliary array? That's very simple. What we are going to do is just going through my array B. If it is ascending sorting, we can go forward direction and going one by one indexes and check if it contains 1 or 0, and um, replacing the values in A by the indexes that contains 1 from B. For example, uh, if I go through array B, I found my index 0 and it contains value 0. That means my sequence doesn't have 0. So I incremented the index for B and go for index 1. Index 1 has 1. So what I'm going to do is replace my 0 index in A for the index that are present in B, that is 1. And I incremented the index of A. For the second value for my shortest sequence, again I go for the array B and look at the next index, which is 2, which also has 1. So I'm going to replace the value in my array A. Similarly, I go from B, I will have 3. I go for the index 4, it contains 0, so I'm going to skip, and I'm not going to index 5, it has 1, so I'm going to replace it. 6 is also has 1, 7 doesn't have it, 8 has it, so I'm gonna replace this. I have the shortest sequence here, right? So similarly we can do it for descending sorting, just we have to go from the last index to the first index. Okay, let's see the implementation of this key index searching and sorting technique. So first step is finding out the maximum. Here I have the code for the maximum. Find out, we consider the first value as the max and go through all the values of A to find out the maximum. If you run this, we'll get 8 as the maximum value. The setup step is generating the auxiliary array B with the capacity of maximum plus 1, and after generating this we are going to have values of A as the indexes of B, that is B of I, which is the value inside an A, will be the index for my B, and we are going to set it as a 1. I have here printed so that we can check the value. Okay, this is my array A. 5 should be in the index 5 and it should contain 1. It has 1, should have 1, it has 1. For 0, which is not present in my array A, it contains 0. That means it's holding all the values present in A. Okay, so here is an example where we can do if we look for a key. So we just have to go to the auxiliary array and check it out if the value has zeros or ones. So look at the 8 number key. We go through my index B, it has 1, that means the value is found. What about the key is 4? It should print me value not found. As 4 has 0, it says value not found. Just only one step we can find out the value, it is present or not. So for sorting, what we do is just going through my array B, and if it is not 0, the indexes of B, we are going to replace the index in my array A. So if we print it, it's gonna show me in my ascending order. Okay, 1 2 3 5 6 8. The sequence was 5 1 2 6 8 3. So we get a ascending sorted order by using